So this one will be more fun because I'm also not using JSONB API all the time at work. So I needed to take a look at the API nodes and the code samples while I'm giving the talk. Basically, this is a funny story. Let me first start with this, which I forgot on the other talk. Since I work at Google, this is not a Google talk. Google is not asking you to use those stuff on Java or JavaEE. So these are all my personal stuff, not related to Google or not necessarily related to my daily job. Okay, before we jump into this. So, is there any C++ guys in the audience? Okay, I blame everything for C++. So Dijkstra, who I really love, I mean, everything except probably this word. Object-oriented programming is an exceptionally bad idea, which could only have originated in California. Which I kind of blame C++ again, until C++ hit the ground and started ruling the software world. We didn't really need anything called design patterns. Somehow projects started failing and design patterns emerged. So the term design patterns first brought by Gang of Four, which is actually 4 guys who wrote a book and known as a Gang of Four. And funny enough, 2 nights ago, a friend sent me a picture from a cocktail menu. They even have a cocktail with the Gang of Four name. That's my career goal now. So, according to Gang of Four, design patterns are descriptions of communicating objects and classes that are customized to solve a general design problem in a particular context. Let me prepare my water. Oh, that's the best thing you can do, quote yourself. So I actually talked with Alex, who is my co-author. If we came up with this or we read it somewhere, we both don't remember that. If you Google the full string, it doesn't come up with anything. So probably we come up with this, but I'm still not sure. So I'm just quoting the book, which actually is written by me. So, but I really like this explanation for design patterns. Basically, design patterns are the collective wisdom and experience of many smart developers. And they which unleash a huge great depth of experience that can be utilized to solve many common problems, which can occur anytime in your software development process. Now let's go back and see how enterprise Java met with design patterns. So the first talk I found about design patterns with Java was from Java 1 2000, which is called Prototyping Patterns for the J2E platform. This has become a book, and which actually stayed as a very popular book for a long time, called Core J2E Design Patterns. And funny enough, until JavaEE 5, to implement a simple design pattern, you need to do a lot of stuff in enterprise Java. However, JavaEE 5 has unleashed a lot of potentials and provided a lot of out-of-box implementations for patterns. So this is from my blog, which reminded me I don't write any blog posts anymore. So that's funny because I lost all my hair with JavaEE. So I've seen EGB 1.0, then we were the early adapters of 2.0, which was at beta at that time. we moved to 2.1. JSF was beta at the time. We moved from struts to JSF. So yeah, this is the result. But at one point in my past, I was like, okay, this just doesn't work with J2EE. And somehow I met with Spring, and I was so happy. But actually, JavaEE has changed with JavaEE 5 and went to a very different direction. So in this, this blog post was actually, if you have watched the How I Met Your Mother, there's a story there where Barney doesn't date girls who doesn't like evokes, because he has a theory: if the girl doesn't like evokes, it means she's old. So only people who are young enough at the time when Star Wars released will like evokes, because they're like very cute creatures. So I kind of realized there's a simple pattern with JavaEE. So people like me who come from the old era of JavaEE, J2EE, kind of be skeptical about the new stuff and how good they can be. But actually things were really good. So suddenly this blog post became popular. It went on Oracle's, I think it was the Glassfish website. Some other people quoted it. There's even a Reddit post about this. I don't know why. And they're really talking about the evoke sample. So, then I started writing a series of posts, and then it became a book. So the book is like, I think it's really getting old, but still most of the material is new, and it has been like translated to 7 languages. I'm still surprised with that, which wasn't the case in my second book. It was obsolete before it was published, because Android Studio got 3 updates before we could publish the book. Never mind. So let's move to design patterns and start with Singleton. So Singleton is a very basic design pattern. Basically ensures that a class will have only one instance, and you will have a global point access to it. The classic implementation is you override the constructor, make it private, use double locking, static initializers. Each have its own pros and cons. But of course, the best way, according to Joshua Block, is using the enums. And one important thing is it must be thread safe, and ideally reflection safe, because if you just do make the constructor private, someone can make it public with reflection. How about JavaEE? It can be really simple as adding just an annotation. So in JavaEE, you just annotate your class with Singleton annotation, and it becomes a Singleton. It's thread safe, reflection safe, and basically it's a very easy way to implement Singleton. This is a new effect, I guess. I can't blame because it's Google's slide, so I'll keep quiet. There are also some other annotations which can help you building up your Singleton. There is post-construct annotation, which basically helps you to run the tasks after the creation of Singleton, which will only run once. And then you can use the startup annotation, which basically tells the container to to create the Singleton at startup. And you can again ask the container to wait for another bean to be initialized before creating the Singleton. All those are like just adding one annotation, and everything will work. So to wrap up, Singleton is a very simple design pattern. And with JavaEE, you don't need any XML configuration. It's very simple to use by using injection. You can basically use that inject with your singleton name and it will be there. Pros and cons. This is like the typical structure of each pattern. We'll wrap up with the pro-cons slide. The good part is you can easily create a mechanism to cover expensive object creation, caching, or global access. The bad is overuse can always cause problems. If you're lazy loading, it means you will cause delays when someone first tries to call the methods on the singleton. If you're not lazy loading, you're basically keeping everything in the memory. So you need to use it when it's right time to use it. And the ugly part is some even consider singleton as an anti-pattern. So again, it can be really helpful if it's used in the right context. Next, abstract factory. It's a creational pattern. Basically, it encapsulates the creation of objects, and if you need to change your code and introduce new types of objects or different mechanisms to create objects, the only part who is responsible for the creation will change. So how can we achieve creating an abstract factory in JavaEE? Where did my annotations go? Okay, I think my slides are messed up a bit. So you annotate the factory method with produces annotation, which basically tells the container it will be responsible for producing any string value if someone is expecting a string. And if any part of your project is expecting a string with @inject annotation, your factory will be providing the needed string object. But what about if there are more than one method which produces the same type of object? Then, of course, our target inject part will not know which, actually it doesn't know anyway, but the container will not know which method to invoke. This can be easily solved with the @named annotation. Basically, you can add names for the methods, and by using the @named annotation at the inject point, you can specify which factory to use. Again, pros and cons. It's very easy to implement. Even for an ongoing project, you can easily annotate your methods and convert it into abstract factory. There's no boilerplate, which is like super amazing, because if you try to implement a factory in any language, I have a Kotlin version of this talk. Again, shameless plug for the Kotlin user group. Even with the nice magical syntax of Kotlin, you need to write more code than JavaEE, which is a huge gain for JavaEE, I guess. And it kind of works magically thanks to JavaEE container. The bad, well, the named annotation, if you're using the named annotation, it's not really type safe. So it might be better to wrap objects, wrap the, if it's something like strings or different objects, it's better to wrap them into objects or annotate them with qualifiers. And the ugly part is if you're using such a mechanism, the flow works kind of magical, which might be a little hard to debug and understand if you're a newcomer to the project. Facade, I still wonder if I should keep this slide. Facade might be the easiest pattern, and I'm not sure if JavaEE really adds anything important to it, but basically with Facade, you hide the complex logic behind the interface and basically keep the clients away from the complex logic. It's typically used in APIs, and the classic implementation is just create a method to hide the complexity. Except in J2EE, you need to create an EGB and the local interface and the remote interface for it. So, of course, that's all time. So, to use Facade in JavaEE, basically, you're using an EGB bean and using injection where it's needed. Again, Facade is like a very easy pattern. Some may even say it's not a really design pattern. You can use stateless or stateful beans. It's very easy to implement, and basically, it's very easy way to write nice APIs and hide the complex logic. However, the overuse basically creates unnecessary layers. And basically, while encapsulating the logic, you're creating hard to change interfaces, which is like something you will be doing in a way with an API. Decorators, okay, that's my favorite topic. I have a story about this, but probably I should skip that. So basically, decorators are magical. They add behavior to objects in runtime. How cool can it get? They're more flexible and extensible than inheritance. And basically, unlike inheritance, you can do it in the runtime. The classic implementation is both the decorator and the target object, which will be decorated, share the same interface. And the decorator holds and wraps the target object, and it can be wrapped by another decorator. So each decorator will introduce its own behavior and change the behavior of the target object. Again, you can do magical stuff even in an ongoing project with decorators. So to create a decorator in JavaEE, you have decorator annotation. And basically, you choose a delegate for the target object. The only part with which might not be as nice as the other patterns so far with decorator is you need to write a very simple XML for decorators, because basically the JavaEE container needs to know which order it needs to decorate. So if we have more than one decorator, we need to add the other decorators in this XML file. To wrap up decorators, the good part, unlike inheritance, it's very easy to change behavior without breaking the legacy code. So it's very easy to implement it after, even after you finish the whole project. It needs an XML configuration, a basic one, but still. And overuse will introduce an execution flow, which will be very hard to flow, especially for someone who is not familiar with decorators.
What's the story?
Oh, the story. So, you really want that? So, in the past, a friend and I, we had our own startup, and we basically wrote a simple software with the hand terminals for restaurants, which the waiter can just get your order and use the hand terminal to send it to the kitchen, which we had printers, screens, and everything, which worked great. I mean, none of us was very familiar with how restaurants work, but we designed everything perfectly until one point. For us, if the price of the product changed, it's a new product, which made sense. I mean, if you are looking for a small sandwich and a large sandwich, if there's a price change, which cannot be added as a string node, it needs to be a new product. Very simple, and it worked. Until one restaurant, which had a full menu of desserts and one item called pizza with 3 different toppings, which we needed to create a combination of all the toppings and enter them as a different pizza option. Simply, our system couldn't handle it, and it was way too easy to fix that with the decorator. I mean, at that moment, while we were setting it up in the restaurant, we were like, okay, we should just stop this deal and run away, because we can never make this work. They have a menu of 30 desserts, and we are like trying to enter 300 pizzas, because we need to create all the combination of all the toppings. And basically, I went on, like, spent 2 hours on a finished software, which we deployed like more than 20 restaurants. And everything worked the next day. So decorators, I mean, for me, it's like the Swiss knife for everything. But again, use it in the context and don't listen to me. That's the story. Next, observers. Observer is famously known for, don't call us, we'll call you. It's basically a publisher-subscriber mechanism. So the classic implementation is Java offers an observable interface, and you can also use listeners via inner classes, which work much or less the same way. So observers let your code work more efficiently by not polling, but by receiving the data as a push. But how about JavaEE? So observer in JavaEE is very easy to implement. Again, you annotate your target with observable, and any class who just fires an event, which is the type of the part which the observable is expecting, will be observed automatically. It just works magical and doesn't introduce any boiler code at all. And you can use objects, just like the previous example. I was using strings. Here we have object types. This especially makes more sense because you may have more than several resources where the service is creating the objects. So you don't want to just end up same object types and using a lot of named annotations. Instead, you can easily wrap them into object types and use the object types as a safe way. So again, pros and cons. It's very, very easy to implement. There's no boilerplate code. The bad part, it may introduce, again, a difficulty in following the execution flow and, of course, debugging. The ugly, nothing. It's basically beautiful. Model view controller. It's actually not a pattern itself, but maybe called a composite pattern because it's a collection of other patterns. It's used and accepted as industry standard in almost all UI frameworks, probably except mobile. Keeps data and logic, logic, and UI code separate. So a change will not hit every part of your code. JSF is a clean and simple implementation of model view controller. So let's talk a little about all the concepts in this pattern. So first, the model. The model represents the data and the related business logic. Most of the time, the model is basically a CDI game. The controller links the view with the model and basically decides how the application flow will go. And in JavaEE, MVC, for MVC, the model is actually backing pins, which are annotated modules with named and request scope. The view is facets, which are written in XHTML and using CSS. And the controller is basically the faces servlet. Next, we have some data patterns. First, entity. So, entity is lightweight domain object which is persistible, which basically means we will serialize and save it somewhere. They are annotated with JavaX persistence entity annotation, and it can represent a relational data object or relational mapping annotations. This is a simple entity, so it's annotated with entity and it's an ID, which is generated value automatically. I'm pretty sure almost all of you come across entity object in the past. Next, we have data access objects, which we will use entities and with data access objects, basically, we will decide how to interact with them. They're used for accessing the persistent data storage. Most of the time, they're represented as singletons, not necessarily all the time, but most. Simple cases, entity manager is the data access object. And complex cases, you can create your data access objects for each entity object. And usually it's a CDI managed bin in JavaEE. This is a very simple data access code. Basically, we expect the entity manager to be injected by the persistence context annotation. Then we can search for any entity object and save or merge them. Next, data transfer objects. Again, this we will add, well, JavaEE will offer a little on top of this, but mostly it's basically an entity. And simple cases, it's really encouraged that you don't create another copy of your entity and use it as the DTO. But the main difference between a DTO and the entity is DTOs are serializable objects which are built to transfer data between layers and systems. They often are annotated via JAX-P or JSON processing API annotations because basically our target is transferring data between systems. So here we have an entity class, and we will tweak it a little and change it to a DTO. So in this example, we may not want all the fields to be exposed outside our system. So first, we need to start with the root XML root element. Obviously, this for XML serialization. The XML root element basically tells the container that the contact object will be a root XML element. Then we have the XML accessor type annotation, and the interesting part, which is like just for example here, let's say we don't want to expose our ID to the outgoing object. Using the XML transient, we'll just hide this value from the generated XML. And some patterns which are not actually can go 4 patterns. Dependency injection or inversion of control. So this is like a religious battle. I'm fine with both names. But if you're curious, you can go and read. There's a huge battle between why it needs to be called dependency injection or inversion of control. And it's a funny one. So basically, it promotes injecting the resources instead of creating them with the new keyword, which gives you the ability of not being tied to a concrete class and change the behavior at test or any other platform. So it can be used via constructor, field, or setter injection. After its success on Spring, it basically replaced most of the GNDI lookups of J2EE, JavaEE. So again, for the old J2EE guys, I know the pain before dependency injection. JavaEE 6 and above offers CDI container, which is in addition to the JavaEE container, which also works with and provides dependency injection capabilities. So let's see a dependency injection example in JavaEE. So we have a Hello World service. Obviously, we have another class which will probably be needed by the Hello World service. So we want the Hello World class to be injected in our Hello World service. And basically, that's it. With CDI, any class can be injectable, and we can inject the class into our Hello World service. If we have more than one possible class to inject, in such a case where we change the Hello World into an interface and create different concrete classes implementing that interface, we can again use the named annotation. In this case, we have a new class called MyWorld, and it's of course implementing the Hello World, but it's marked with named annotation MyWorld. So again, with @inject, we can use the @named annotation, and we will end up with the right expected concrete implementation. Dependency injection is powered by CDI. Multiple implementations based on an interface, and basically anything is injectable in CDI. So let's see a little about how example with CDI. Here, actually, maybe it might be better if I show the code first. So here we have two different types. We are looking to inject, we are looking to use the message type long and short. And for that, we create our message annotation with the appropriate types of short and long. And next, we can use it with CDI. So dependency injection, and especially CDI, for CDI, it's all inclusive. No framework or library support is needed. It's all in JavaEE stack. The CDI offers much more than just a dependency injection framework. It improves testability, removes hard dependencies, and being tied into concrete implementations. However, dependency injection, if you're new to it, again, is kind of black magic. Things just created on their own and appear in a reference variable. So if you're coming to a new project and not familiar with it, it might be a little challenging. For the ugly part, seriously, it just makes everything much, much nicer and simpler. Next, actually, it's not really a pattern, but I couldn't just stop myself to add this to the slide set. Actually, this remaining part was not in the original deck, I guess. Timer. So it's very easy to create timers with JavaEE. You just add the add schedule annotation and define your time constraints, and the container will just run the methods for you at your specified times. And you can use wildcard characters and decide and make more flexible schedules. Interceptors, again, not sure if it really qualifies as a pattern, but you can easily declare interceptors. Here we have a web filter, again, only created with an annotation. Basically, it will catch every matching URL pattern and will put the filter in place before the servlet request is reached to the servlet. And similarly, you can use the interceptor annotation with around invoke or other options to again intercept and basically create your aspect-oriented like code running on top of the existing code stack. I think this might be the final slide. Finally, asynchronous. Asynchronous method calls is also very, very easy with JavaEE. You just annotate it with asynchronous, and your method will become an asynchronous running method. Of course, if you need to return a type, you need to do some additional work. So yes, that's the end of the design patterns talk. And if you have any questions or any additions to the patterns, which I might be lacking, love to hear.
Questions? With regards to dependency injection and choosing the name injection, so counterintuitive.
True. I mean, yeah, mostly it was light purposes to show your options, but yeah, I wouldn't be advocating to use named annotation a lot, for sure. But that's also in the stack and can be helpful in some scenarios.
We're using the Singleton annotation. It's the project constructor generated or somehow like anything to stop me from instantiating class despite the fact that it's annotated.
So that's a good question. Let me go back to that slide. Actually, we don't need to. So so the typical Singleton implementation is, of course, marking the constructor private so that the outside world cannot use the constructor. In JavaEE world, it's a bit different. So basically, here we are dealing with beans, and you can still technically use reflection. However, the instantiated class will most likely be missing the parts you have been injecting or using instantiating using the post construct part. So can you create a concrete version of this class if you're not overriding the constructor and throwing an exception there? Yes, you can. But in the end, it won't be the bean you will be expecting in the JavaEE container. So yes, it will be a granted enterprise bean in the JavaEE container. In terms of, I'm basically trying to understand if you're trying to see it's really a singleton or just trying to test its logic or other stuff. Yeah, you should definitely use the embedded container for the tests, not like creating anything with new. That would be a very different scenario, a very different object and very different behavior. So whatever you're doing or testing, unless you're, I mean, actually there's no unless, yeah. You shouldn't be just doing with a new keyword. True.
Just means I
True. And to
injection, just same thing. There are two creators that have injected.
yeah, I agree. I mean, historically, Spring and JavaEE has affected each other a lot, and it has always been really positive in my point of view. I'm not against Spring. Actually, the last project I worked with a client, I used Spring instead of JavaEE. So they can work together well, or they can replace each other. And they basically offer much or less the same functionality in a similar way. Any other questions? Good. And I hope I was on time and leave you guys back home not late. Thank you.